Good evening, everyone. Good evening to all the participants of the online FDP on generative AI fluency organized by NASCOM and sponsored by AICTE ATAL Academy. Uh, Thank you so much for joining in. My name is Kamna Jain and I'm with NASCOM. And welcome to the fourth day of this online FTP program. I'm getting some queries on the assessment, so I'll just give some instructions for all the participants. Participants are still joining in, but all participants need to log in and sign up on the Future Skills Prime platform. There you will find your group of AICTE ATAL online FTP participants. Please go on the groups. There your course is assigned Generative AI Fluency. There are 33 modules in that course. So please complete that quiz. And on the sixth day, there will be an assessment for uh, which will be on the Future Skills Prime platform. This assessment you will take on Saturday at 6:30 p.m. after the completion of the sessions. Many of you have got the promo codes. I think some of you have not got the promo codes. I will take it up with the team tomorrow and we will make sure that you get but I'll request you to check all your inboxes. Sometimes the promo codes may be going into the promotion tab, or they may be going to junk mail, or they may be going to spam mail. So I'll request you to check that. Once the FTP is over on 11th, after that, on Atal portal, you will go and fill the feedback form, which will open after the FTP is over. And your certificate will be generated only after you fill the feedback form, which is on the Atal portal, where you have registered for this online FTP. If there are any other queries, please put your queries in the chat and I'll be happy to answer those. We'll now, after the logistics, we'll move on to the lesson, and whatever questions you have for the lesson, we have very eminent speaker today and who will guide you. So I will urge you to put your questions related to the topic in the question box. We will be happy to take your questions. So without further ado, let me introduce the topic and the speaker for the first session today. Our topic is Gemini AI, generative music, and generative audio. And we have a very eminent trainer with us. We have Dr. Prakash Goteti. He's a subject matter expert working with Tech Mahindra, where his focus is on infusing artificial intelligence and agile technologies into business processes to catalyze transformation and growth. So what involves is designing sophisticated learning solutions and contributing to national skill development initiatives, leveraging his expertise in AI, ML, and project management. With a background as an assistant professor, he brings a robust academic foundation to his role, which enriches the mentoring and development programs that he handles. So I'm very excited about this session and the learnings that we will take away from this session. Over to you, Dr. Prakash Goteti.
Yeah,
Please.
thank you so much. Thanks, Kamna. Thanks for this opportunity. Very good evening, all. Today we'll be looking at one of the interesting applications or rather use cases of generative AI, where we will be looking at how generative AI can be used in music and movie industry, right? So specifically, we'll be looking at key aspects pertaining to model development and what are the intricacies associated with data representation of music, and it is little abstract and slightly complex representation, but I will try to give some inputs on that, and wherever required I will use some explanation purpose, I will use the blackboard as well, right? So this is the overview. So if you look at our journey, right, we started with generative AI, right? in the beginning. Then maybe we touched upon certain aspects pertaining to architecture, and then I will be focusing on below pointers like Gemini AI, music fundamentals, generative models for music, etc. But before that, our understanding of AI as a discipline and generative AI as abstract model should be very, very clear in order to appreciate this session. That's why I have made certain pointers which are of very important as far as understanding of this particular use case is concerned. That's why even though certain aspects you are familiar with, but I want to ensure that you are very much clear on that. That's why I put certain bullet points to ensure that all of us are on the same page, and uh, we are very well versed with the terminology and the abstract models associated with this particular discipline, right? So so I just brief about the uh, ecosystem of AI. It is a discipline. So overall discipline, if you look at artificial intelligence, you must have heard many times that it is focusing on creating uh, uh, reasoning based applications like autonomous cars and self-driving cars, etc., right? So fundamentally, if you look at artificial intelligence, we have two types of AI. One is a strong AI and other one is weak AI. Whatever applications that we have seen in day-to-day life so far, they are based upon predominantly weak artificial intelligence. Because like humans, right? They cannot sense smell, for example, right? Similarly, uh, how do you react or response very quickly, so that there are certain aspects where we still are in the process of developing those models, right? So machine learning, all of you know, it is again a branch of artificial intelligence, and it is essentially to learn from the data and improve the performance of the model over a period of time and without explicitly being programmed, right? Deep learning essentially is based on deep neural networks. A neural network is abstract model, and understanding this abstract model is very important because we have been using lot of terminology in generative AI. But sometimes what happens is we might be jumping directly into a generative AI. There could be certain gaps. So I want to ensure that we are very clear on that, because that is very critical for me when I explain data representation, model development pertaining to music. So these fundamentals are critical. That's why I'm just touch basing on those aspects, right? And then you have a generative AI. Again, it is a class of deep learning models where instead of interpreting data, you will be generating new data, right? So these are data generators. So uh, if you look at uh, data generators, right? They actually stemmed out of machine learning, because in machine learning we have two types of models basically. One is discriminative model, other one is generative model, right? So a discriminative model is based upon a mathematical function where you will be predicting a response variable based on certain independent variables, or variables which are independent to certain extent, to be more precise, right? On the other hand, when you look at generative models, they are based on distribution functions, right? Probability distribution functions, because once you have a probability distribution function, something like a normal distribution, right? Once you have a data, right, you can always plot a normal distribution or whichever distribution it is from the data by computing parameters, right? For example, in the case of normal distribution, the parameters are, what are the parameters for normal distribution? Can you tell me? Let me check chart. What are the
Please
parameters?
answer. Yeah. Please put your. I'll request all the participants to engage and answer
Yeah,
Dr. Reddy's question so that we know that you are with us and you're taking all
yeah,
the
yeah.
goods.
So, what are the parameters for normal distribution?
Please type your answers in chat.
I have quiz also, by the way, in this. So, it is very important for us to pay attention. So, let me explain.
Deviation. I think there is one answer.
Yeah,
Vivek
it is
Prakash ji is saying
basically
mean deviation.
yeah, it is mean and standard deviation, right? It is not deviation. So, what I suggest now, when we actually learn these concepts, we should be very, very clear and we should be very precise on vocabulary, right? Like the way we have vocabulary in English to communicate in this discipline, we have very, very clear words, right? Specific words to be used, right? So that's how you will be generating data using some of the distribution. But sometimes what happens, you want to construct a distribution which is more complex, and you want to generate that from the data itself, right? So how do we do that? That is another interesting problem. Then we have agentic AI. What is an agent? So if you anyone, can you answer what is an agent? No, we should not look at agent as a person, because we are talking about application development using artificial intelligence, right? In that terminology, what is an agent? Let's say, suppose you must have attended a lot of sessions, series of sessions till now, where you learned about specific use cases of generative AI, like for example, uh, a bot application, right? How a bot works when you say Q&A bot, question and response bot, how this bot works. There are certain LLMs that are used to train these bots, right? Now, if I want to encapsulate this entire bot into a reusable application, where, like the way you have a customer care representative responding to users, right? You wanted to use this entity called agent to do the response to the queries from the users, right? So that is essentially encapsulation of the application that you have already developed, right? So that's what agentic AI is precisely, and at a higher level. But it has a lot of other intricacies. So that's why, as I said earlier, all the concepts pertaining to AI, machine learning, deep learning, this to be very, very clear, and we should have the ability to differentiate them very clearly if we really want to understand and appreciate any of these uh, areas, right? So, okay, we go to the next slide. So we all know that data is of three formats, right? Structured data, semi-structured data, and unstructured data, right? So what is semi-structured data? Can anyone tell me? Very good, very good. That means when you talk about structured data, essentially you have a conformance to schema, where you may not have that kind of conformance to schema in terms of data type information, right? Because in structured data, you have a conformance to schema and type information as well, right? Every column, if you take relational data model, you have a set of columns, and where you specify that this column is of where type, or this is of number type, etc. When you talk about semi-structured data, like you rightly mentioned, Vikrant, right? XML, where you annotate the data into using different tags, right? So that provides some kind of schema conformance, but type information is very difficult to embed in this. On the other hand, unstructured data means It can be a video type file or audio type file where it has neither schema conformance or neither schema conformance nor type information which you can preserve very easily for effective and efficient retrieval, right? So on the right hand side, you can see the discipline that we have, right? We have AI as a discipline broad area. Within that, you have machine learning and then deep learning, generative AI within that, and we have a specialization within that agents. Now we are in this in the fourth inner circle, generative AI. So unless dots pertaining to all these are connected properly, we will not be able to appreciate the models and abstractions associated with generative AI. So that is the intent of putting all these. And the second thing is I wanted to ensure that all the dots are connected. So now if you look at artificial intelligence as a discipline, right? This is very nice pictorial depiction, right? How each of these things are connected with each other. Now you have machine learning as a discipline, and you have natural language process, you have a speech recognition, which includes translators like speech to text, text to speech, etc. And then of course we have a robotics and scheduled optimizers, right? Then vision models. If anyone wants to uh, get a specialization in this discipline, right? One need not have to be expert in all the domains, right? These are the various domains that you see here in this diagram, right? One is machine learning domain, natural language processing is another domain, speech is another domain, and of course vision is another domain, right? So it depends upon whichever interest that you have. For example, if some of you want to pursue research in this field, and then potentially you can pick up one of these domains, right? So that's how it is. Now, again, when you look at machine learning as such in terms of a bigger picture, what we have essentially uh, is a kind of hierarchy here: supervised learning, unsupervised learning, and reinforcement learning. And generative AI, when you look at, we are more on working with, uh, kind of a mixture of supervised and reinforcement learning. So can anyone answer what is reinforcement learning from the chart? Award reward, correct. Yeah. Mm, So reinforcement learning is the fundamental abstract model behind agentic AI, right? When you talk about developing agents, agents will have two things. One is called a percept, right? Which is essentially what you are experiencing from the environment, right? From which you are learning. And other one is additional input that can be from uh, other component, like it can be a database or it can be a rule engine, depending upon from where you are supplying additional data, that additional data and additional information, more precisely not data, will be used to take better decisions, right? But when you take these decisions, each decision is associated with a reward and a penalty. So these are the aspects which you normally familiar with in reinforcement learning, and the application of reinforcement learning that you see in agentic AI. Now, remaining things I will just skip because in supervised learning we have various models. Supervised learning deals with labeled data. Unsupervised learning with is just it can be labeled or not labeled, but there are separate type of activities as you can see it here. I don't want to spend time on each of these uh, classes, but just for your quick recollect, right? Now, when you get into this journey of generative AI, right? Most important thing is understanding abstract models, right? So let me just pause here and let me share with you. Uh, 1 minute. Let me share. Yeah. Can you see my screen?
It's coming up.
Yeah. We'll wait. Let me know if you're able to see this.
It's still coming up, yeah.
Yeah. No problem. I will just write something here. Is it okay? So
Please write something, then we will know.
yeah, I will write.
Yeah, yeah, we can see your screen. We can see that you're writing something on the screen as well.
Yeah.
Yeah, your screen is visible.
Discriminative model and other one is generative models, right? Is what we want to understand. So suppose if I plot a feature space, suppose I have some features. If I plot this, right? Let me use some data points like this, right? And now assume that you have constructed a model. So this model is of the form something like y is equal to mx plus c, where c is your y-intercept. So all the data points which are this side of one class, these are of other class. This is basically discriminative model, right? Generative models or probabilistic models are let us say, suppose I have uh, data points in let's say single feature data points, and I want to, based on this feature, right? You want to predict some y, maybe you want to predict a gender or whatever, right? So essentially you have a function here which is mu sigma, right? Which is nothing but, you need to be little familiar with math, okay? Without that, this discipline very difficult to understand. It's not like software engineering, you know. You need a lot of understanding on math. I know that it is not yet, you did not get much chance in these 3 4 days, but it is important for you to understand this. So these are basically data generators, right? Because given a distribution like this, assume that your sigma here, sigma is called half width at half maximum, right? Half max. So you can create a slice like this in equal intervals. We have 1 sigma, 2 sigma, etc. I don't want to get into that stat part of it, but essentially, once you have a distribution function, I can always generate a new data point provided my mu and sigma are given, right? So data generators we are talking about here. So similarly, when you are having classes, right? When you have class distribution of positive class, negative class, when I'm talking about labeled data, so this label data, based on the label also, we can plot some distribution like this. So now how can I separate two distributions more meaningfully? That is based on the probability. If there is a overlap, you just say that your class label, your class, whether it is positive class or negative class, is argmax of the probabilities that you compute, right? So it returns plus or minus. So this is how your generative model works, right? So this, because you are talking about data generators, implicitly you will be having these kind of functions, right? But uh, you cannot generate data just by using these uh, well-known functions, because real-time data might be much more complicated. So you need to construct a data distribution function using these models, right? That's where this generative AI is coming into picture. You are not interested in understanding the equation of that model, and we are just looking at the consumption side, right? In consumption side, what happens? You just look at what is the new data that you got, new image that you got, right? So, but underlying math is very, very interesting. That's why I wanted to discuss on this. Now, let us go back to the slide. Give me a minute. Let me reshare. Yeah. So you are okay with my switching between board and this, right? Otherwise, I will write here only. So now you understood, right? What is the difference between discriminative model and generative model? Any question on this?
There are no questions in the chat
Yeah.
box right.
Yeah, yeah. I'm just checking. So now next concept, next we need to understand is in the journey of generative model, we need to understand something called a large language model, right? This is the fundamental element in uh, or primitive component in generative AI. Without discussion and understanding of large language models, generative AI is incomplete, right? We should internalize these concepts. So large language models are general purpose models. They can be pre-trained, just a minute, and fine-tuned for specific purpose, right? So what is large in this, right? It is trained on massive text data or video data, whatever it is, right? But essentially the representation is numbers. That is one thing you need to understand. Whether it is a text or video or audio, the internal representation is numbers, right? So you are training essentially on the large volume of data, and you do some kind of pre-processing where your uh, model can understand your input, right? So fundamentally, in a very, very simple terms, right? Your large language model is essentially, we can think of as a something which is constructed from neural network, right? All of you know neural networks, right? Let me check the chart. You know basic understanding of neural network. I'm just checking chart. What is neural network? Because these concepts are very important for your assessment also after completing your course, right? So it works like human brain. Uh, no, no, this is just, where normally when you look at internet content, right? These are all English descriptions of how an abstract model works, right? So let me just explain you briefly in 1 minute. Uh, I will share this again. You can see my screen, right?
Yes, we can
Yeah.
say a speed.
So a neural network is something like this. Suppose you have some inputs, values, right? You are giving some input values to some function, right? This function is represented as node, and this node is connected with other set of nodes like this. And then we have some output layer. So these are nodes. Each node contains two things. One is, you know, some computation. Suppose you put some weight on this edge, you put some other weight on this edge, right? You keep putting weights, and essentially what you compute here in a simple term, suppose you have two inputs, x1 and x2 going to a node like this. Here you have a weight W1, you have weight W2, you have W1 x1 plus W2 to x2. And to ensure if both of them zero, your value should not be zero, you put some bias term called W naught. So every layer you add some bias, right? So this is typically neural network. Whatever weights that you see here, right? These are called parameters, model parameters, right? So what will happen if you have more number of nodes? What will happen if you have more number of nodes in each layer? These are called layers. This is called input layer. This is called hidden layer, hidden layer 1, hidden layer 2, and this is my output layer, right? Now, when you are essentially computing something like this, assume that you have only two inputs, only one node. In this place, it has two parts. This is your weight 1, weight 2. You simply say that W1 you multiply with x1, you multiply with x2, and you have some bias term W0. That is the first half of this node. Second of the node is some nonlinear function. So if you assume this is some z, you compute f of z, right? So what is the purpose of nonlinear function? Suppose you are giving some image, right? Some cat, right? Now this is converted into set of features, right? It has set of pixels. They are converted into feature vector. Feature vector. This feature vector is given to this neural network, and as part of this network, what happens? One interesting thing will happen. So the layers which are peripheral, right? Which are outside, right? They will be able to define uh, uh, lower complex city features, right? Now, if you get into more deeper, you will get more complex features. That means the peripheral layers will see outside boundary of this image. When you go to inside, like the more deep that you have the layers, then they will be able to recognize nose and mouth, etc. So these nonlinear functions that you see, they are helping you to define uh, features, right? Mathematically to what you see nose in an image. So more complex images you want to classify, the more deeper you will go. That is one aspect. Another thing is you also increase, vertically the nodes. Now, for example, if you say this is your neural network, now the number of layers that you want to have in this network and the number of nodes in each layer, they are supplied from outside, right? When you are setting up the network. So hence these are called hyperparameters. So when you work with generative AI, also you have something called model tuning. So we keep talking about model tuning. We need to understand what exactly happens. In model tuning, what happens is you are tuning your hyperparameters, right? What is hyperparameter? Hyperparameter is a parameter which is defined from the algorithm and which is supplied from outside, which is nothing to do with your data, right? It is not part of it, but you use it to tune that model using these hyperparameters, right? So this understanding is very important. Now, okay, all right. Let me go back to the slide. You're okay with this approach, right? Anything, please, difficulty, put in the chat box. Then I will just focus on the PPT only, presentation only. So now you understand how these models works, right? So you have something called transformers. Again, transformer is this kind of models where you have the encoding and decoding mechanism. I don't want to again get into that, considering our objective of this session, right? So, so you wanted to explore these to construct new uh, content, right? Whether it is a text or image or whatever, right? So, so this is what you do. You learn from the data, the statistical relationships. Why suddenly we are saying statistical relationships? Because as I said, we are talking about data generators, right? Suppose if you give you always see that this image is generated by AI, right? So that means new data is generated and it is actually transformed back to the way that we've seen, right? Initially. So you do the data generator, you apply data generator, you construct a new data which is in numbers, right? And those numbers you transform back to get that image, right? So that's how your data generative models works. And then you do fine tuning. Fine tuning can be done through predominantly the input that you provide. So for example, prompt engineering. How do you do fine tuning in prompt? Because we'll also use prompt engineering in this session. But are you clear about how to generate the prompts and how the prompts are generated? Can you write down some best practices to generate prompts? What exactly happens if you write a prompt? No, no, act as a catalyst. Uh, no, no. You answer my question. What is a prompt? Don't tell me English definition, okay? You just put it, let's say, what exactly happens when you type a prompt. As you give as input to a LLM like Gemini, or you give it to, Chat GPT, for example, right? What exactly happens? Your prompt is English text, right? This English text is get converted into vector of values. These vector of values are converted into numerical sequence, which you give it as a feature vector. I understand. You give natural language input, but natural language input, how your large language model understands, right? Because its input is a feature vector. So you convert these words into some feature vectors using different techniques. You must have learned like TF, IDF, etc. And then these numbers will be given to model, and model will generate another numbers. Those numbers transformed back to output, right? So, uh, right. Let me just go back to this. Yeah. So you understood what is a large language model, what are the things that will happen. You understood the concept of neural network, I suppose. And so when you say prompt engineering, you design prompts. There are multiple strategies, right? Zero shot, one shot. You remember from the yesterday's session, or you don't remember? What is a one shot prompt? What is zero shot? You think about it. Right, let me continue. So now we are clear about uh, the vocabulary, right? What we are talking about in this. So this is your architecture for generative AI model. This is baseline architecture where you have random input vector, which you already explained, right? So you have a generator model. Generator model is again abstraction of the neural network and other variants of neural networks together as a black box here. So you have a model for uh, generator. So you have a generator model from which you are generating new content, and that new content is becoming an example, right? Because a new content is generated, and that content you want to check with real original content, how close it is. And to check that, you are using a discriminator model. I already explained what is a discriminator model, right? So the discriminator model will classify whether the example that you have generated is looks like a real or looks fake, right? So you wanted to improve the quality of the new example that you have generated. For example, you give a line image to generative AI model, and you want to generate a new image, or you want to give music. You will see now very, very interesting things are coming up. uh, when you give new music and you want to synthesize it to construct new thing, and you first fine tune this model, how close it is with respect to the feature set that initial real example has, and then you fine tune this model. That's why you have this uh, feedback loop, right? You have a dotted line going back to generator model. So that's how your model learns from its previous inference, and it will improve subsequently its performance, right? Now, similarly, you keep updating your discriminator model because your generator is also a model, right? And the discriminator is also a model, right? So both requires fine tuning, isn't it? So that's why you have a feedback loop. So now let us look at summary of models. So you see a lot of models, right? Internet. Now these are the models that you have. Uh, One is uh, GPT type models, and then BERT models, Falcon. You don't have to worry about this. So essentially, you understand the architecture and the strengths of each model. So in case of uh, GPT is basically decoder and auto-regressive model. It is good at text generation. That's why the GPTs are good at generating the code, programs, text content, and all that. And then the other can you have this model. This is basically BERT model. encoder only, bidirectional model, and the certain models like Falcon, which is based on decoder only, which is used for text generation and optimization, so on and so forth. So this is basically to get overall understanding of various models that we have. So far we covered generative AI overview and the various architecture components. So any questions so far, please type in the chat box. I will check. Are you okay? Are you understanding the session?
Please type yes or no. Please type in the chat box.
Okay. Any question? Okay, good. So now we are getting into uh, generative AI specific to Gemini, and then we'll get into music aspects of it, right? So, so Gemini, if you see here, uh, it is again AI chatbot tool designed by Google. It is a kind of a conversation model using natural language processing and machine learning. So the fundamental concept of natural language processing involves few steps, right? Let me just go back here, and I want to reshare my board. So hope you can see my board, right? Yeah. What is NLP? So let us say you want to do text-based model, right? Suppose the book content is good, right? Suppose if you say something like that, or the movie is very exciting, right? And the pizza is not tasty. Suppose you have these kind of text inputs, right? What do you understand from this text? You see that this is something like a positive feedback. This is a positive feedback. This is a negative feedback, right? So this is essentially sentiment analysis. You must be knowing this, right? So how it works, each of these words, right, they are converted into features. So there is again a life cycle in natural language processing, right? Where you will be throwing unwanted words. These not required, right? You throw it off. Book is required, content, good. These may not be required, right? These are the keywords kind of a thing. I don't want to get into the model part of this, but I will give overall picture, because without understanding this NLP, how these things work internally, we keep talking about generative AI, but that discussion and understanding is incomplete. Now, these called my features, the keywords or words of, you can see my screen, right? Or my features, and these features you convert them into vectors, feature vectors, that is numerical representation, right? When you convert them into numerical representation, then you know that after that same story you will give it to this large language model and you get some output. Because one often wonders, how a simple text or content or image, whatever you are giving, how it is getting into something very, very realistic to you. What is the abstraction that is making this possible, right? So, so you will, when you have simple text like this, you will be performing certain operations on this data. One is called lemmatization, right? Where you group or related words, great, greater, something like that. You choose one. And stemming, you remove extra characters, and then remove stop words. Stop words means the, is, to, those kind of things. And then we will be using some transformers, right, to make it into more machine or model understandable format. That's all about NLP here. So let me go back to the slide. Now you understood, right, why this is NLP and machine learning stuff here. So when you think of Gemini, right, so you have a content which is coming from various platforms, which is like your websites, messaging platforms, and so on and so forth, right? So Gemini is a multi-modal AI. What is multi-modal? You can have a combination of text, video, combination of audio and text. That is the critical thing when you want to generate new music, right? Because uh, we have a voice and we have something connected with image, and you want to create a new avatar and somebody is playing music, etc., etc., right? So this is again data you need to represent back in the way that I explained, but approaches might be slightly different. I will explain you that as well, right, as part of this session. So this is some historical significance of Gemini. So it is actually first version. It is like uh, 2023 from Alphabet, and then you have 24. You have Gemini 2.4, right? So let me go to the next slide. Now, how do we compare here, right? How do you compare Gemini with other GPT models? What is GPT? Generative pre-trained transformer models, right? So what is a transformer model? I explained. What is a transformer model? What are the components of transformer model? Hello,
Please type your answers in the chat box,
I will check.
participants.
Yeah, very good, Sonali. Text processing, representation, very good. Tokenization, fantastic. So that understanding is important. We don't have to perform these tasks for prompt engineering or generative models, but having understanding that is important, because then only you can give right prompts. Yesterday you must have learned about personas, right? What kind of personas we have in prompt engineering? What are the design patterns in prompt engineering? All that you must have learned. But the story behind that is representation, tokenization, because you want to reduce that pre-processing work for your model. Because you imagine that your model is doing a lot of pre-processing, right? Then what is happening? You are actually wasting your resources, isn't it? So if you design a good prompt, then it will give better response. Okay, garbage in, garbage out, isn't it? So that's why it is very important. So now you see the comparison of generative pre-trained transformer models. Transit transformer model, we have encoder decoder mechanism, which I explained short while, right? From now, we have a feature. These are under various feature categories. These are compared GPT-4, and these are important for your quiz also. That is the reason I prepared this content. So please just don't look at it as some, theoretical stuff. So multimodal aspect. So GPT-4 text-based and designed natively as multimodal model. It is in Gemini, it is coming as a more natural thing, right? So in GPT, we can analyze and describe images, whereas in Gemini, you see you can describe images, analyze videos, and answer questions. Audio understanding, in terms of audio understanding, it is limited. It is natively processed uh, a mechanism, right? Various formats that it will support, struggles with multimodal tasks. That's where your Gemini comes into picture. So for music synthesis and filmmaking, these kind of things, it is a multimodal data that you are interested in, right? So that's where Gemini is very good. Now, this trends other domain type of thing reasonably well, both comparisons. If you see content creation also reasonably well, unless you have again multimodal content like the mix of images and text embedded in them. And education research, both are okay, right? And we'll have some visuals we can create in Gemini. It is clear the differences between GPT models and Gemini. Why are we learning why are we learning Gemini here specifically for music? Because I said in the agenda that you learn, understand Gemini architecture and they get into music, right? So you should understand why it is so. Is it clear? Any question? Please be interactive. Any suggestion also you can type. If I have to go slow, if I have to fast, you can tell me that. No problem. Okay. Now again, I want to compare these um, pre-trained transformer models with OpenAI, right? Segment. So these are in terms of model size, you have 200 billion parameters. Here 175 billion parameters. So what is the what do you mean billion parameters? You see that your neural network I explained you, right? The parameters are weights associated with that network, right? So suppose if you create more complex model, that means you are increasing number of parameters, isn't it? Now Gemini more complex than Open Chat GPT. Why? Because that is a different purpose for Gemini, because it has to understand multimodal data, right? So your feature complexity is high. So as I told you, when you increase the number of layers, right, you are getting the ability to process higher order features. Your model learns higher order features, isn't it? Because for you you can understand that there is a dot near your near that image, let's say, uh, because if you see birds predominantly, right, there is very small difference between two different varieties. Similarly, if you want to classify disease prediction in plants, there's very minute difference. Those differences are very difficult for humans, right, with naked eye, because of this feature extraction ability of networks. When you increase this number of models, obviously you should have computational power to deal with so many parameters, right? So that's what you need to understand in this. And again, in terms of performance, it outperforms it outperforms certain areas like math, coding, etc. And accessibility, this is very straightforward thing. Cost, it's more cost effective. Energy intensive. What do you mean energy intensive? Because when you compute, right, there are multiple processes are working, they're parallelly, but they generate lot of heat, lot of radiation, right? So that's why we are talking about green computing, right? So if you type blindly some prompt, indirectly you are penalizing that large language model, and several bottles of water you are wasting actually by giving a very poor prompts, isn't it? So we should be very cautious when you are making certain choices, right? With this, we can make that careful choices provided we have clear and concise understanding of how things work. What are the abstractions, right? Now I have questions for you. So does not take the support of optical character. I have not covered this in the class, but still I wanted to ask this question. Generally, our human tendency is that suppose if somebody is asking, right, whether a particular model supports this answer, if you say true or false, we always say it will support whatever it is, but unfortunately not. Okay, you will learn this from your course because I wanted to give some kind of synchronization between what you learn in the course and what I am covering here, because I don't want you to treat this session as some knowledge sharing session or some exposure session. I want to see that this has some meaning for your course. It should be in sync. Okay,
Thank
so
you.
see.
Thank you for that. Thank you for so much for that. I think people are answering that it is a false.
Yeah,
That the correct
but it
answer?
is true.
It is true.
Mm,
Gemini does not take the support
yeah,
of OCR.
yeah. And in that context, like, so now let us see this. Out of three variants of Gemini, which variant is has a small, simplest AI model for mobile devices? This is a common sense question actually, but let me see
Oh, sorry.
what it is. It is Nano because this, as the name suggests, right? So let me just. Kamna, you're okay with these questions, right? I'm putting it here, some
Yes,
questions
please.
from.
Thank you so much. I really appreciate this.
Yeah. Now, see here. Can you read this question and answer? Can you just guess? That is also fine. Gemini can be used for creative writing and scientific research. However, it cannot be used in education due to its lack of imparting personalized learning experience. Is it true or false? You need to be very, very careful in your choice. Unfortunately, English is ambiguous, right? Because we can have our own interpretation. So, so see what is the reason it is saying it cannot be used in education due to lack of imparting personalized learning experience. Because whole bunch of work that we are doing in generative AI is to get personalized experience, isn't it? See, you may not recommend in education because of some other reason, ethical issue aspects and integrity aspects, but not necessarily because of personalized learning experience. So the statement should be false, isn't it? Correct? You should not think that it cannot be used in, you should not see that it cannot be used in education. Just by looking at it cannot be used in education, you should not tick, you know, option. You need to be very, very careful in our understanding. That's what I'm trying to say. These questions are very nice. Now, look at this. I gave you brief overview on ChatGPT and Gemini. How does Gemini outperform ChatGPT? What options you want to select? You can put numbers 1, 2, 3, 4, 2, 3, 1, 3, like that. No problem. I wanted to see how many of you really understood this. Hello. 1 and 4, very good. Right? Because it's cost effective. So now I completed Gemini. You understood the concepts of Gemini?
What's the correct answer?
Correct answer is 1 and 4.
Okay, thank you.
Now, now we are getting into music world. You should be very, very excited now because so far we have connected all the dots. You might be thinking that we have only half an hour, but it is very, very interesting. Let me tell you. Now we are talking about music as a data, right? So what is the data representation for music? let me just tell you. There are three types of representation. Sheet music. What is sheet music? You see symbolic representation, right? Second one is audio, then instrumental, isn't it? And now you need to understand three things. One is forms of music, and what are the research possibilities that you can leverage generative AI, and what are the challenges, right? So what are the challenges that we see in data with respect to data representation? By now you must have understood how important data representation is for these large language models, right? Limited annotation in data sets, because these data sets should be annotated properly. Then expressibility of the content, right? Because if you change a small tune, that will give different experience, right? Style, imitations, and creativity. Style aspects as well as creativity aspects. Musical structure you need to see, right? What is our motivation? How I want to see generative AI? I want to see generative AI in terms of bridging the creativity and technology. I want to see generative AI in terms of unifying music modalities, various modes of music. For example, somebody is playing sitar, right? And you want to put the drums. You want to take assistance of AI to put drums. How do you do that? Right? Empowering musicians, right? And you need, first thing is you need to understand the music representation. So let me just run through this slide, then I will go to the board, because we have a little bit limited time. Switching back between board and this will be slightly difficult. So these are different data formats for music: raw audio, sheet music, and instrumental. And you see right hand side, feature extracted formats, spectrograms and HDFI. See, normally spectrograms are used for Python scripting, right? Because you can generate this music using Python code also. Very interesting, right? So now I will play small video. So, sorry, audio. You let me know if you are able to hear this. What is happening? 1 minute. I'm resharing this. Ah, can you hear?
Yes, we can hear.
What do you understand from this sound? You must have seen some background music of Bahubali movie, right?
The video didn't play proper full.
No,
We
no,
just
there's
heard.
no video, only audio only.
I mean, the audio also, there was a very little audio that I heard. Not able to recognize. Can you play it again?
Yeah, yeah, let me. I enabled sound actually. I tested it. You also enable sound from your end, maybe. It worked well. When I tested. Now, if you see here the representation of data, right? This is your representation. We have a talam, and you have a pallavi, and you have a notes, which you can see here, right? So how your machine understand this data? This is converted into different formats. Like this is the frequency time format, and uh, this distribution, if you see. On the other hand, if you use different format, something like amplitude format will lose your temporal temporal effects. So that formatting is very important. So all right, now this is what uh, pre-processing. When you talk, see, when you talk about what is your data set in music, your data set comprises of, let us say, several compositions. A composition comprises of notation and audio, right? Notations I already explained in the previous slide. So what is happening is your notes in the music are encoded, and there is a periodicity which you call them thala, right? So mathematical representation of thala is periodic function, right? So because your models can understand only mathematics, So I have some other things also because I think we have very less time. So now this is one example I want to show where Fibonacci sequence is used to generate this. Will take some time. I'm just playing this. Let me know if you are able to hear.
Yeah, we can hear.
So similarly, you must have seen because it takes little time. I am skipping this. Let me go to the next slide. So these are the different music in the point of view of mathematics. That's my motivation of previous slide. So these are basically multiple things. You need to essentially work with the spectrograms, right? Frequency visualizations, how this energy varies with frequency. Amplitude is not a good measure. Frequency and time is a good measure. These are the various transforms that we have: short time Fourier transform, constant Q transform, because that's how you extract features from the music, right? Because your model should understand the representation, its own representation. So that's why you are using this stuff. So this is about music fundamentals. Now I am looking at how generative AI is being used outside. Uh,
Human collaboration with intelligent machines. A different musician in a different town with a
can you
different
hear?
approach is giving the same problem a shot.
Yes.
People are concerned about AI replacing humans.
This is being done
And
on
I think
generative AI and
it's
music.
not only not going to replace humans, it's going to enhance humans. I'm Gil Weinberg. I am the founding director of Georgia Tech's Center for Music Technology. Ready? In my lab, we are trying to create the new technologies that will explore new ways to be expressive, to be creative. Shimon, it's
There are use cases where
playing robot.
physically challenged person
What it does,
who
it's
can
listen
play
to humans playing,
flute, but they want to have a
and
different
it can
background.
improvise.
They can use generative AI for syncing that.
Shimon is our first robotic musician that has the ability to find patterns through machine learning. Machine learning is the ability to find patterns in data. So for example, if we feed Shimon, Miles Davis, it will try to see what note is he likely to play after what note. And once it finds its patterns, it can start to manipulate
see
it.
my
And I
screen,
can
right?
have the robot playing in a style that maybe is 30% Miles Davis, 30% Bach, 30% Madonna, and 10% my own, and create morphing of music that humans would never create.
This?
Gil's groundbreaking work in artificial creativity and musical expression has
Can you
been
hear
performed
me?
by symphonies around the
So
world.
can you hear me?
Yes, yes, we can hear you.
Yeah. So
Human collaboration with intelligent
you
machines.
can hear this. You can see and hear, right? This video.
Yes, yes, we can. We can.
Uh,
A different musician in a different town with a different approach is giving the same problem a shot.
People are concerned
so
about
this is
AI
one thing. Let
to
me
play a game
go to
like
the
I
next
used.
one. This is very interesting. You see this. Let me 1 minute. Let me put in the presentation mode. There could be some issues, you need to bear.
Sound is gone now.
Can you hear at least little bit? Because this is not very.
No, the audio is not very.
No, I am speaking. Let me be on mute. So just go to the. Now see this. See, this is a very good use case where uh, dolphins, right? It has been proved, I mean, inferred. There is a hypothesis that the sound of dolphins will, that noise that dolphins make, right? They have a significant healing effect on humans, on something like Alzheimer disease and certain lifestyle diseases, right? But you cannot bring a dolphin and make a noise at your home, right? So how do you synthetically generate those kind of noises, and how AI can be generated? AI can be used for music therapy, right? This is a use case on that.
When I was 12 years old, I would page through the encyclopedia. I would stop on the whale and dolphin page and I would go, I wonder what is going on in the minds of these animals. Language to me is the ultimate question about intelligence. The thing that we haven't been able to nail without a great tool. You know, how do you decipher another species? The main use of dolphin gemma is to eventually look at their natural language patterns and match it with the underwater video. That's how we really figure out their language if they had it. All right, beautiful day. Woohoo!
Imagine a world where you could talk to an animal. Dolphin Gemma is the first LLM for dolphins. We've leveraged over 40 years of Denise's vocalization research to create this large language model to generate new synthetic dolphin sounds. These sounds will help us to one day hopefully communicate with the dolphins.
Dad shows up at my office one day and he's wearing one of his many wearable computers. And I'm like, ooh, this guy's like a techno man, right?
I was like, well, I do wearable computers. This sounds like a summer project. We'll get this done for you. Here it is 15 years later. We've engineered this Chat Junior device to play our synthetic dolphin sounds underwater. Let's see which one this one is. That is the signature whistle for Denise. So whenever she's approaching the dolphin, she can introduce herself.
So what they're doing is they're testing the distance at which the two chat boxes can efficiently recognize our synthetic sounds. Oh, there we go. All right.
We want it to work close to 100% before we take it in with the dolphins.
It's this dance between getting data and respecting their culture.
You know, I'm not very seaworthy, so.
You did great.
The true breakthrough for me with Dolphin Gemma is that I can generate so many of these so quickly. I just scroll through here and do days worth of work in minutes. If we can use this open model, people would take advantage of Denise's 40 years worth of research and use it to model for their own purposes.
Science is most exciting when you find something you're not expecting. You may discover something that you never even thought to look for. And that's the beauty. You don't know what's coming.
Yeah. It is very exciting, right? Especially for faculty fraternity, and you will be excited in the sense that not just using generative AI, but developing certain models, maybe small LLMs, which can be customizable for our actual needs, right? And it is very important. There are many use cases. Actually, I don't have much time, but like Shankar Mahadevan, right, versus music AI. There is a very interesting experiment, and similarly AR Rahman, and you know, multiple use cases you can find on your own, and you can use it. You can just open your Google and type Gemini and type something. I did not get time to do that because I don't want to make my session very hectic and uh, cumbersome, right? So because the information should sink in, right? We should understand what we are talking about, how it is. Now, what difference we can make? This is very important, right? Because as faculty members, we are all faculty. Everybody who learns can also teach, isn't it? So ultimately, everybody is a teacher. Essentially, what difference we can make is how do we nurture this young talent? That is very important at the end of the day, right? So simple thing, we have to impart coding skills in a right way, from program language oriented thinking to programming oriented thinking to program independent thinking. What does it mean? Which means that we are moving away from syntax driven intricacies to abstractions. Unless you understand these abstractions, the way we teach abstractions, it is very difficult to, pick up these skills later on. With that note, I will stop here. Thank you so much for your time, and I hope session is informative. Any questions, I will take.
Thank you so much. I think this is it's also a very eye-opening session in terms of the concepts and how there are some questions. So I think I will let you answer. The questions are in the chat.
Yeah. Yeah, what are the research areas in music? That is a big thing actually, because see, I did a lot of literature survey for preparing this session. That's why I could curate certain things, right? So I am literally speaking, I am not a music expert. Let me tell you, I don't know music actually, but I try to understand the intricacies, how music is represented. As a student, I just try to explore this with and try to come out with this. So there are multiple things that you can do, and you need to pick up a domain at the end of the day. Otherwise, we just attend some sessions, but unless you pick up something, then we cannot progress, isn't it? So that is very important message. I feel we should take. Thank you so much for the opportunity. Thanks,
There are
Kamna.
some
Yeah.
questions.
Yeah, sure. So
How
that's the first question I already explained. Second one is, what are the current open challenges in applying computer science techniques to music research? See, fundamental thing I did not cover that the representation. There is an entire life cycle in music processing. That life cycle I could not discuss in this session, right? So once you see that life cycle, you yourself will understand that the pre-processing steps and the feature engineering steps are more critical, because any small minute uh, deviation will lead to noise, right? Music is very sensitive to noise, isn't it? So that is one critical thing. Now let me go to the next question. Can AI models learn cultural or stylish? Yeah, it depends upon, see, cultural or stylish for you. Once you convert the data into a numerical representation, that is up to the machine to understand, right? Isn't it? Suppose if you say that you have a paint a parrot, right? A painting of a parrot. Assume that parrot is in a green color. Now suppose if you give a yellow parrot, how it is, it definitely works, because at the end of the day, what your abstract model is doing is it is converting your representation to a mathematical representation and more complex form. If your input is more complex, then it has to do more work. That's why in prompt engineering, we have one shot, two shot, all these techniques. So we should be very, very sensible when you are giving the prompts. Thank you so much. Hope that clarifies.
Uh, yeah, hope that clarifies. There are some others. Dr. Gopal has also raised his hand. Sir, if you want to ask your question, please go ahead.
Thank you. Thank you. Very nice. Very nice half an hour that I was listening to you last past half an hour. When I logged in, it was nice to look up for the Annamacharya Kruti Brahma Kadigina Padamu. There is something
Yeah.
which is called a music experience.
Yeah, yeah.
Right now I am at Gwalior. It's called Music City of India. So when
It's where
it's just a coincidence.
Tansen, his mazar is there.
Mm.
Yes.
So
Telugu
thank you so
happens to
much,
be
first
my
of
mother
all, for
tongue, so it's nice.
giving me this topic. Actually, I discovered a lot of things myself, and I try to package it, considering my background and our audience interest. Hope this is interesting. Otherwise, you let me know what else is required offline. I will do it, Kamna. Thank you so much.
Yeah, thank you so much. I think uh, Sonali has one more question, that can
Yeah.
AI models learn cultural or stylistic nuances in regional or classical music forms?
Yeah, that's what I said. When you look at form, that is a form for you, right? When you get translated to representation of the data, again, that is just a computational task for the uh, generative model, right? So
Right, right. I hope that answers your question, Sonali. Any other questions? Please let us know. We can. He's here
the
with
entire
us
life
for.
cycle is there actually. I thought the time is not sufficient. Otherwise, I could have covered how exactly that processing works. So doesn't matter. I mean, we cannot put too many things, right? Clarity is
Yeah,
very
yeah.
important because connecting all the dots important. They have been attending a lot of sessions, but connecting all these dots important for this topic because this is very, very specialized topic. So
Right. How we train the data to these AI?
okay.
Sure, Sonali. Sonali Singh, she asked the question because of
Yeah,
on behalf of.
correct.
Good.
So how do we train? That's what I said. There is a life cycle where you convert this into numerical representation and then you do some pre-processing. Like for example, you convert the nodes into one hot encoding. If you are familiar with one hot encoding in machine learning, right? And tala, right? In music, those tala will be mapped to modular arithmetic sequences. See, what are these models, right? These are all sequence models, right? What is sequence model? Sequence model will extract semantic information by looking at the context associated with that. So what interesting thing that you need to understand is music is also a context driven, because when you are playing some instrument, when you change, right, a swara or whatever, there is a context attached to it, isn't it? So that's how it is.
Right. So on the dot, thank you so much. It was very, very informative. And there are some more questions, but we don't have time. We're almost out of
Yeah,
time. So
correct.
I think in the next forthcoming sessions, we'll probably have you back
Yeah.
and you can take
Sure.
more
Let us
questions.
see. Thank you so
Yes.
much.
Thank you so much. Thank you so
Thank you.
much for your time.
Bye.
We now move on to the next session of today. And the topic is using GenAI effectively, communication, presentations, and writing prompts. And for that, we have with us Dr. Gopal. And uh, Dr. Gopal,
Hello, what happened? Yes, sound. Am I
yes,
audible?
sir. Sir, your video is off. You need to.
Yes. I'll just do that. I'm sharing the screen. Just give me a minute.
Sure, sure.
Just give me a minute.
We are already familiar with Dr. Gopal. He has hosted one more session for us earlier. So I'm not going to, spend any time.
Thank you. Thank you very much. Let's get on to the discussions very
Yes.
quickly.
Yes.
And I'm sharing the screen.
Yeah.
And yes, I hope the screen is shared.
Yes, sir, we can see your screen.
Okay, going to the full screen mode. So in the earlier session that I had interacted with all of you, it was a talk based on the latest generative AI tool called pre-trained. It's generative and pre-trained and constructed in a manner where the sheer volume of the data, the modality of the data, whether it is image, video, nothing is a concern. And it's a worldwide global data set. in any form and format, the relevant content is fetched in a jiffy. Bandwidth is no concern. Computing power is no concern. Nicely called large language model. Idea is good and it's delivering wonderfully. Today, if we are meeting for another session, it tells that in such an important topic we are addressing, generative AI. And as I mentioned earlier on, the Future Skills platform has put together 33 modules, which are so nice on letting us go through the real power of generative AI across various domains. I'm sure by the next edition, we may hopefully come out with some other domains, the legal domain, the many things that we can think of. In other words, in the last talk, I mentioned that 30 disciplines that are likely to be highly impacted by this technology, which is doing wonderfully well. However, positioning the technology in its perspective, more in the way in which an academician looks at it, AI is a very big challenge. It has been there for 7 decades. Presently, we are able to progress from what we began with as addressing perception, hearing, vision, computer vision, acoustics. Those were the two sensory ideas of a human being that we very quickly wanted to see if the machine can assist us. That processing, even in the last lecture, Dr. Prakash was mentioning, what is that complete processing that a human brain does may still be another decade and a half away. The strong AI is yet to come. But then at the weak AI level itself, we are seeing such a fascinating outcome coming out of an idea called a generative pre-trained model, large language, millions of parameters. It's a generative AI. So what we began as using this wonderful idea that came about in 1955 as a simple answer to the question, can machines think? So when we talk about processing of the brain, what should come to our mind first is thought. What is that thought? Still we are not clear. If anything is happening in the brain, it is thought. So what is that thought? Is it simply a huge collection, unknown, unlimited, unbounded collection of data? The Turing machine, if you look at it, models like infinite tape. So gradually we are trying to answer that question through practical implementations, and generative AI is a very good illustration of what a computing power can do in terms of data which can be in any form, any format, anywhere in the world. All that you need to give are a set of keywords, which in your mind is a question in the making. The question need not be fully formed well. Can AI do this? Can there be a communication on what is called lightning? It is something that you are also thinking. You are trying to find an answer. A question in itself is a thought, a way of thinking, a way of finding out. That thought is making you feel curious, making you feel inquisitive, making you feel well prepared to learn something which you are not already aware of. That is exactly what we are attempting to do. Pre-trained data set is useful to make that LLM happen. But then what it is doing for you is generating based on that pre-training something which none of us really thought till recently, 2-3 years back. So let's see what is my next topic is using generative AI effectively for communication, presentations, and writing prompts. This is another important topic. I did leave a thought with all of you saying that can you do an experiment with slightly adjusting slightly adjusting the prompt keywords. Yes, Kamna.
Dr. Gopal, you can switch on your video also. It
Is that
can,
so?
yes. Even
Okay.
if you switch on your
Okay.
video, we can see your screen and we can see you also. I think that will be good.
No, the video is switched off only for a routine bandwidth conservation.
Okay, cool.
Very nice.
That's
I'll
fine.
do that.
That's fine. Sure. Sure. Makes sense.
I'll do that. Let's see how it progresses. We can do that. Okay. Please
Yeah.
help me out with the chat questions. Anyone can
Yes.
just interrupt through Kamna.
Yeah.
And once Kamna interrupts, I'll be able to answer. So this is
Yes.
what we are looking at today. This is what we are looking at today. Bounded volumes, anywhere, anytime, anybody. All that is coming to you on computer screens. Tomorrow, it's not merely playing around with the words in the prompt, but playing around with multiple threads. They will combine parallelly because human brain is supposed to.
We can't see you. We can't hear you. He got disconnected.
The video to conserve the bandwidth.
Yeah, that's fine.
Okay.
You can share your screen.
Right.
I think you got disconnected. You can just share your screen now.
Okay. I will do that. So this is where we are. We are, as I mentioned in the last slide, we are not likely
Your screen
to
is not
see
visible.
all.
Your screen
Oh,
is
my
not
goodness.
visible.
My goodness, extremely sorry. Let me see what's happening. Coming back to this. Right. Is it visible now?
It's coming up. Yes, it's visible
Okay,
now.
good. So effectively, this is the context we are getting into with generative AI. The bounded volumes, form and format is of no consequence, scanned and kept or whatever, some human reader is helping, somebody is reading it out, it goes into the chat GPT, generative. They're all parallel, massively parallel. Everything appears on the screen. You can be anywhere. You can be reading a book by the side, relevant topic, keep reading as I lecture. Anything can happen anywhere. The background of the individual is of no concern. It's a huge library kind of a thing, which is having a great assistant called LLM. But what is this LLM? Where are we putting in perspective? As I said, artificial intelligence is a very, very strong problem, very complex problem. 7 decades before this idea happened. And we started with what is called perception, vision, and speech. Two most important perceptions, both associated with directly with what's called the brain. Then what we did, we moved into the next phase, machine learning. Then came deep learning with neural networks. Currently, we are looking at generative AI, which is like this. Attempt is to understand that entire gamut of natural language processing, which was a very, very serious problem. Three and a half decades back, not many were working in this area of NLP, natural language processing. Within that generative AI, NLP is a subset. All is not expressed in natural language. The modality is different. We have multimodal. We have many things like that. LLMs is what is catching our attention right now. Large language model. Anything can be a language, you see. It is just a matter of expression. If you look at it. Within that LLM, what is our focus? ChatGPT. Let's proceed further. Natural language processing is at the intersection of computer science and linguistics. So when we moved into computer science realms, our language got a different idea. It was something called a grammar. It is something called without any context, whereas linguistics is very serious. This intersection, NLP, has been at the core of trying to see if we can make some sense, meaning semantics. Can we understand one another? The semantics. However, it is still a challenge, and we thought that machine learning is the best because it draws inferences. That's what we thought was understanding. How does it do that? It raw text is there, tokenizers, text cleaning, POS tagging, stop words, clean text, and machine learning model. The model is obvious. A given sentence is there. We are mercilessly breaking it into words. Wherever we are, see, look at music. Music is a different domain in itself. Are we talking the same way of working with music? Is it something that we can correlate? All challenges are still there for all of you to understand, work, and produce, let's say, 10 times more innovation than what's happening now. The classical NLP is known, the deep learning is all about neural networks. We moved to the third phase, and soon after, we started working on what is called the generative AI. This is just there for completion of what I began in the last lecture, NLP. Then we talked about LLMs and ChatGPT. That's just about a picture that I wish to develop. We started with AI, focused on perception, artificial intelligence, that is vision and speech. Then moved to machine learning, then deep learning, now generative AI. It is a domain that we are talking today, NLP, LLM, and ChatGPT. Natural language processing is still a challenge. We have not yet come to NLP, though the LLM, ChatGPT give an impression that we are doing natural language processing. All the content is in natural language. It's our English, as a matter of fact, multilingual. But please be clear in understanding positioning LLM. It is a good tool, a great tool of a library that is like this. A fantastic tool, which was unimaginable even a few years back, 2018, 2019. However, the beginnings of this was in 1966. Joseph Weizenbaum created a piece of software called ELIZA. While ELIZA was capable of engaging in discourse, it could not converse with true understanding. Please remember that word, understanding. ChatGPT is not understanding, it is generating. The same story of Taj Mahal and a cow should always be with us. To repeat it, for those of you who have missed, a student was very, very confident that the maximum mark fetching question will be an essay on Taj Mahal. Marked up a great essay, one of the finest essays written on Taj Mahal. Went to the examination hall. To his horror, the question was write an essay on cow. Now he didn't know what to do. Thought for a while, got a brilliant brainwave. Once upon a time, there was a cow. The cow was grazing in front of Taj Mahal. Taj Mahal is like this. So you see, we need to understand the fact that learning is fine, understanding, comprehension. We started talking right in the very first lecture. We have been listening, but Puneet Agarwal was talking about Bloom's taxonomy, how it progresses towards knowledge. So we have to position our exercise of LLM and ChatGPT in a perspective that tells us that world is not even a limit, perhaps. It's something, wherever the data, whichever form the data is generated, in whatever manner, which is the source, what is generating is of no consequence to me. The LLM is doing a great job of generating answers which are brilliantly cogent, up to the point, and all of us are seeing its usage across virtually every domain. We talk about 30 different disciplines. Many early users were convinced of ELIZA's intelligence and understanding. despite Weizenbaum's insistence to the contrary. Weizenbaum, who created this program, was always cautioning, please do not believe that it is all intelligence and understanding. But many people get that impression that it is highly intelligent, it is understanding what is happening. That's how the experience was. It's again a good researcher, Joseph Weizenbaum, who was writing on what he created as a topic. Please see, it's an old rudimentary text-based screen. You can't even write a complete alphabet as an alphabet. It is not a GUI interface, it's not a graphical card, but that's ELIZA. It was created in 1966. And many people who were interacting with this ELIZA were obviously going away with an impression, much to the violation of the observations by its creator, that is both intelligent and understanding. 2005, Schizen, an automatic CS paper generator. 3 MIT students fooled the world of scientific journals. They created an automatic paper generator in computer science. Nature created an article in 2021. Hundreds of gibberish papers still lurk in the scientific literature. Please understand, this is exactly what is happening with LLM. Unless you know how to go back to the foundations, you may not be in a position to ascertain for yourself that what you got out as a Ziffy from the generative AI is correct, accurate, full of intelligence. How will you conclude? It's useful, but like any typical way of automated generation of content, we should always be there to apply our own way of looking at it, contextualize and use it. Otherwise, we cannot rule out all these. It's just an academician's way of positioning what is happening in ChatGPT. After the ChatGPT does the wonder in 30 major disciplines that are impacting you and I every day. 30 major disciplines. That's a wonderful output you will get for a few keywords, which are in the process of making you think of a question. As you write, as you think of the question, the output comes in a flash. Useful, extremely useful. But what is the hazard in that? The hazard is this. You can write a paper that has no human input. You can produce gibberish papers. 2017, Google revolutionized text generation. This is what I was mentioning last time also, that I was there with the Google Developer Days in Bangalore. Google introduced Transformer, which rapidly became state-of-the-art approach to solve most NLP, by far the best in the natural language processing idea. So I would still think that in the generative AI, NLP forms a major chunk. The ideas of natural language processing form a major chunk of work. OpenAI is the way in which generative pre-trained transformer GPT, ChatGPT, is stemming from generative pre-trained transformer model. As the name suggests, reposes transformer. Automatically, we were thinking that what we were doing is transformational because the tool is called transformer. When the tool was being generated in the making, the Google people called it transformer. But then it is hoping that will become transformative. Language and recognition, lot of statistics, handwriting recognition, speech recognition, image recognition, reading comprehension. Somewhere around 2020, we are getting a feeling that there will be language understanding, the feeble beginning. Otherwise, what we have been doing from 2000 to 20, forget about 1955 to till now, from 2000 to 2020, the 20 years, 2 decades, we were only doing recognition, handwriting recognition, speech recognition, image recognition, reading comprehension, and then language understanding. How did that language understanding begin with? We began with what Google termed transformer in 2017. Until then, we were not at all doing anything called progress towards understanding. We were only recognizing. A for Apple. Anybody can parrot it. B for Bombay. Anybody can parrot it. However, did we understand what is an apple? Not necessarily. Not at all necessary. That apple is a fruit. Apple has a story that can be narrated and connected to Isaac Newton. No, we didn't understand it like that. A for apple. Recognition. Even a child will tell that. Tell A, apple. B, bat. It comes. So we were a far cry from what we thought will be understanding. However, we found some hope by 2020 that maybe we will facilitate some understanding because of the learnings that happened earlier on from 1955. Otherwise, recognition, optical character recognition, speech recognition, image recognition, all these put together recognition, we can recognize. But did we understand? That's something which we'll have to look into. So there is a distinction. The slides will be left with Kamna. I'm sure that she will host it somewhere where people can read. There are so many differences between NLP and LLM. LLM is a proper subset of NLP. Still, the natural language processing is something that is so advanced. We still do not know. As we keep talking, the human brain is capable of doing so many things concurrently. It's a massively parallel exercise. But then we don't have that many ways of expressing simultaneously. The mouth is only one. You will have to sequentialize. Speech will have to sequentialize. But then there are ways and means. The elegance of linguistics is such, as I mentioned in the earlier slide, the elegance of linguistics is such that up to 10 concurrent threads or maybe more, up to 10 definitely can be expressed in a sequential statement. One statement is enough to communicate 12 different parallel ideas that are happening. 10 most certainly in my head. That is the power of linguistics, which we are still not yet exploring. We'll have to still think. Some people tell music will get better power. All these we'll talk later. Types of language models. Language modeling is not happening yesterday. It is just that the rudimentary machines made us go for context-free grammars. Machines have advanced. Processing power has advanced. Therefore, we are seeing more language models. Statistical language models, pre-trained language models, large language models, neural language models, transformer language models. So whatever we called transformer should be 2 levels above what is called LLM. To qualify it as a transformer, just about beginning to understand. Therefore, we are very truthful to what we are doing. It is generative. Large language model gave us the first confidence that yes, we can generate. We don't have to create the content each and every time. Or in other words, what we marked as highly creative idea 1 year back is just there. So many people have done it before. LLM will fetch it to you in 2 minutes. In 2 minutes, you can dismiss that idea as nothing original. Just a thought, something thoughtful that we can think of. Types of large language models. LLMs are also in many different types. Reinforcement learning, few shot and zero shot LLMs, hybrid models. So therefore, we are now looking at only one LLM. LLM created by OpenAI and named as ChatGPT, Generative pre-trained transformer. Still a long way to go. It is only generative. We are hoping that it will become transformative. That is, what I thought is this, but it is giving me 10 creative directions as output. Potential questions. How did this happen? I don't know. It is happening. It's just reporting. So many people have reported like this, and it's just giving it back to me. It is not doing that next leap in our thinking. Size and model complexity. Well, as is the case with everything, we have to do a computational idea. We'll have to think of LLMs and then compare it with what is it that we can do as contextual understanding, resource utilization, bias, use cases, plenty of use cases. Right from the first lecture, we have been seeing a lot of use cases. Bias is there, inference is there, control is there. So what we are talking about are really large language models which have their strengths, weaknesses. ChatGPT is an LLM from OpenAI based approach. OpenAI created this ChatGPT and it is based out on a LLM. Generically, there are many LLMs. Each LLM has its own strength and its own weakness. But for the topic that we have taken up, good, bad, right, wrong, ChatGPT is the leader in the field. And it's doing exceedingly well, and all of us are looking at the 4th day on ChatGPT. Strengths, knowledge intensive NLP, human language translation, you can read it up. There are strengths, there are weaknesses, there are opportunities, there are threats. So if time permits, I will go back. Some of the threats are very important. Inference latency. It takes time to infer. To simply put clever cut and paste, it's easy now. Tools are there. Unlimited data is not daunting us from attempting. We'll simply put together. It makes sense. The model is so sensible that it generates a very cogent and a coherent essay. Inference takes time, even for us to read through. The gaps are obvious. You please study the outcome of a ChatGPT. You still want to put some points of your own if you are familiar with that domain. If you are a domain expert, think that's a good start. It's a great literature which is leaving some points which we'll have to explore further, learn on ourselves, and fill. It takes time. Inference costs, security and privacy concerns. Well, we don't know what is going on the network now. Hallucination, alignment, model drift, prompt drift. There is a drift. It drifts. The model dictates. There's a golden rule. A decade and a half before, we were working on these models. The common statement which we all used to share on creating a model to work with, all models are wrong. That is the premise with which we start. Some models are useful. LLM is exceedingly useful. ChatGPT from OpenAI is extremely useful. The best of the lot so far. We can easily say that. And it's impacting how many? 30 domains of what we are doing every day. That's a huge impact. The architecture, which is borrowed from Google, it's called transformer. Google called this transformer. I'm not planning to do so much of lecturing on this. However, typical lectures on this topic will budget about 3 to 4 lecture hours on transformer architecture, how it does. It's for the records. So what is it that we are talking about is output probabilities. This is what we are good at now. What are the probable alternatives? And pick one. That model is exceedingly good on making those probabilities shine. Very likely answer. Is the sun going to rise tomorrow? Probability says yes. That's all we can do. So what is it that we are talking about? Are talking building probabilities in potentially, let's say, thousands of alternatives. It is quickly deciding this is the most probable answer. Cow is blue in color. Can cow be blue in color is the prompt. Please try it out in your chat GPT. Write an essay on blue cows. What will it tell? It will tell so many things. Blue cows are rare. Cow and blue color do not go together. Same idea, same point, but it's not conclusive, but highly probable that you are looking at something else. Not likely to happen. You'll get a feeling, but it's not conclusive. It's inferential to the best. What are transformers? Generative. Generative based on what? Deep learning. Why deep learning? Neural networks is a very good mathematical model. It is not necessarily so very elaborate, a simple idea which appeals to what you and I think we are doing with the brain. There are neurons, connected neurons, and we are doing it. Appeals to what is happening. But did it cover all neurons that are firing? By the time I decided to speak, I might be using only, let's say, 20% of all the neurons that have gone behind in making the thought happen before speaking. That's all we can tell. We're not using the entire neurons that were fired by a thought. So we are still a long way off. But it is called a transformer. It's a good effort. I met the team. They were working on it. Google Developer Days. Just beginning of that 2017 kind of a thing. It was very nice to see that happening in the making out of Google. And now it is virtually catching our attention. Wherever we go, they are talking about this. The autoregressive concept means that output of a model, such as the prediction of a word, the terminology is associated with what is called a transformer. At least 3 to 5 lectures should be there on transformer to understand what it is. You see, it can take anything, music, image, text, others. Anything can happen. Recommends, movies, books, flight destination, drug discovery. Anything can happen. Such is the power. At that time, I didn't visualize, but then people were really serious that it will happen. OpenAI's GPT will happen. It is happening. Encoder decoder based, the many transformer models, as I said, we are talking about what is called the one that is governing our chat GPT. It's a decoder based. GPT-2, GPT-3 are decoder based. Even if it is something which is happening as an encoded text, this particular transformer is able to decode for us, used for tasks that require text generation. It is written in some notation. It is written in some style. Each one has a different way of describing the same thing. Let's say, ages back we were talking, even in programming, write a C program to multiply three-dimensional matrices. Each one will generate a different program to solve the same problem. It's not the same line, same sequence, same syntax. Writing an essay, we have a characteristic way of writing. Either it is the Bloom or GPT-2, GPT-3, it's a decoder-based idea. ChatGPT is a conversational AI built on OpenAI's GPT architecture, designed to simulate human-like dialogues. Please remember, 1966, that is 10 years after the term AI was coined, Joseph Weizenbaum created ELIZA, which was trying to do this. People were thinking that was intelligence, much to the violation of the cautions by the creator. They were doing its great intelligence. It's something which we have done it. But then it is still, now you see the difference. ELIZA was just the beginning. It was spotted as a great idea. First introduced publicly in late 2022, ChatGPT has rapidly become just under 3 years. Widely adopted AI products globally. 18, it was GPT-1, introduced by OpenAI, 117 million parameters. How many parameters are there in this LLM? 117 million parameters. I still remember during the statistical modeling, 30 parameters is a big ask. It was genetic algorithm. 30 parameters is a very huge model to work with. Now in 2018, what is the thing? 117 million parameters. That means that LLM is so fantastic as a model and so fast. Nothing is daunting us. The seemingly infinite data, the multi-model representation of whatever human endeavor is, in terms of painting, in terms of this, whatever it is, 117 million parameters is not a joke. And it is happening in a split second. How much computing power? Even now, I am worried about the bandwidth conservation, but then I will still venture once again to see if I can make the video come up. Let me see what happens. If it is coming up, it will be good. Video is on, I think. And am I still sharing the screen? Hello? Is the screen shared?
Yes, screen is shared. You are
Okay.
also visible.
Thank you.
Yeah.
Thank you. Thank you so much. Let us see what happens. We'll do that experiment. So now you see, we are talking about a way in which we are moving across such a huge model. 117 million parameters is not a joke. What happened? Okay. Okay. ChatGPT 2, 1.5 billion parameters. See how much of improvement. 117 million parameters to 1.5 billion parameters. What is the pre-trained exercise? Web text of 40 GB of high quality web text. That's how the model was trained. Always neural networks work like that. We should have a session on neural networks to understand that there's a training set and the model is now doing on its own. It will tell you what is the outcome of a new context based on what was the earlier training. So trained on a web demonstrated coherent paragraph level text generation in 2019. 175 billion parameters, not 1.5, 175 in 2020. You see the progression of the model. 2018, 117 million parameters. It's a wonder. 2019, 1.5 billion parameters. 2020, 175 billion parameters. The richness of the model is so fascinating. And ChatGPT 2022, from where the fire caught on. Now we are seeing what is the import of all that happened until 2022. Reached 1 million users in just 5 days. 5 days, it is something which is wonderful. ChatGPT, the popular chatbot from OpenAI, is estimated to have reached 100 million monthly active users in January, just 2 months after launch, making it the fastest growing consumer application in history. Reuters is a very reliable reporting agency. So it is something fascinating that we are going through. It is a nice of NASCOM and AICTE to have approved this course, and let's see how far we can go ahead. March 2023, GPT-4 released in March 2023, it has significantly improved reasoning and accuracy, added multimodal capabilities. So we can progress, we can go on. But the best of the lot happened in 2022. It is great. It is more than 175 billion parameters. And in just 2 months, 100 million monthly active users. turbo and custom GPTs, we can talk. This is the progression. What did we do? The genesis, GPT-1. Scaling up, GPT-2 in terms of number of parameters. Deep learning, GPT-3. Conversation mastery, GPT-4. However, many people who went through 1966 ELIZA by Joseph Weizenbaum think that there is something which he pointed out as a great potential when the displays were very rudimentary. You cannot even display a character properly on the screen. Outside of the dot matrix idea, we didn't get any better way of displaying. Evaluating ChatGPT's performance and other language, variety of metrics and benchmarks are used. How many people have benchmarked on the performance? You please see this. You can have one of those performance evaluators, LLM-based metrics, reference-free metrics, reference-based metrics. BLEU is a very popular parameter. You can take your query, take your output, estimate a good metric. Please remember, what you cannot measure, you cannot improve. And when we measure, we want to improve. These are all great metrics that have evolved, not one or two, and ChatGPT is shining. When so many people are looking at it, and if it is showing good scores, it's something which we should take in. Very reliable. However, please keep that question alive. Why should I accept the output coming from ChatGPT each time when you are seeing the output? Maybe it is one page, maybe it is 2-minute reading, maybe it is 5-minute reading, but you please question yourself. Why should I accept this? And go ahead. It's necessary to ask that question. A battery of metrics are there. Reference-based metrics, reference-free metrics, LLM-based metrics. Approximately historical timeline, rise of LLMs. We are still looking at BERT. BERT is very good on log models. It's an existing metric, BERT. Anything that you give, how many millions of people are logging into the machines? Just give that much of data. BERT gives you a great outcome of what is the story of logins, authentication, authorizations. It's exceedingly good. That model is tuned like that. So anyway, these are all there. They are traditional NLP models. Always we should say this is the outcome. How do we measure the quality of the outcome? These are the metrics. LLMs have to go through these metrics. The mushrooming of transformer-based LLMs, OpenGI is still the market leader. There's no doubt about it. What we are talking about GPT is this. There are other names. The same idea, the same thing that we are talking, generative AI, is found through Google, PAML, Lambda, OptML, Cloudy, Ernie, Bloom, Pangu, Megatron. But then it so happens that we are talking about GPT. It's so nice idea. 3.5 million parameters are there. I drew your attention to a potential threat on drift. New research from Stanford and University of California, Berkeley highlights a fundamental challenge in AI development that's called drift. Drift occurs when improving one aspect of complex AI models leads to a decline in performance in other areas. Simple definition. Please understand that all these different parameters have contradictory demands. Any systems designer will understand that if you want to put 10 functionalities, each functionality will pull the design in one direction. It is a classical case of balancing act. Sometimes it's a knife edge walk, sometimes it's a thin rope walk. In any case, as we are making it more and more impactful at a very high level, we should be very careful on what it is that we are doing. It's a knife edge exercise in making the correct compromises. Now, this is only text generative. We are making some easy compromises. We are not really involving the life forms. But then as we keep telling, the medical doctors are showing great progress in using this tool. But they have native expertise. They are not medical doctors through ChatGPT. They are medical doctors through the dint of experience, dint of hard grind of experience, making use of this tool called GPT. You please give it to that medical doctor, the output, they will tell you what it is from their perspective. So please ask yourself that question, why am I accepting this many lines of text generated? Then proceed. First, we must have a problem to solve. And we should understand when a solution arises, it is a solution. A classical statement that we make is, for somebody who does not know where he or she wants to go, any road is okay. So if you have a problem defined, half of the exercise is done. A typical researcher always says the same. A problem well defined is half solved. Old idea. So you please approach this tool. Fantastic tool, billions of parameters, unimaginable model, which we are talking. It all happens in a jiffy across the networks. So what we are really doing is have a problem. If you know how to define the problem, there's nothing like it. Let's see how to do that. So there are commercial APIs. You can have it as an application programming interface. That's what we are doing most of the time. Most web browsers will now come with a plugin. You don't have to. As a matter of fact, it's happening now. You just punch into the Google bar, automatically the first set of results are generated by a ChatGPT. Generative AI. It's all just automatically done, plugins. Privacy concerns may arise, no specific hardware requirement, and prompt engineering. Use a foundation model. This is what I have been trying to attempt. A plethora of open source pre-trained models, many are there. LLM, ChatGPT combination is currently the best of the lot. It's doing well. Now, what is it that we are talking about is communications. Any questions on this so far? I'll stop here. Take questions. That may be better. For a while, let's try it out like this. Any questions?
No questions up till now. I think it's quite clear.
Very good. So just before we go to the communication, now why are we worried about communications? The world today acts on communications. It is not merely a generative idea which is there, which we want to read, which we want to consider, weigh options. Today we are acting on communications. You see how much of volume of communication is going on. I simply take up my mobile phone and then place a request for a cab. Actions are initiated. They're actionizable now. There is no more theory around it. I want to order food, actionizable. Swiggy or whatever it is. Is the screen still shared? Hello? The screen is not shared as yet?
It is quite visible. Your screen is
Okay.
visible.
Okay, very good, very good. So communications, that is when it is a communication. This is what we are talking about is more like writing up some prompts, see what it is coming. The corpus of data in any form is no more a concern. Computational power, no more a what is the computational power we are talking about? Toying around with billions of parameters. Million is all over. Billions of parameters. Each parameter is a dimension in itself. That was the programming challenge we had. With 30 parameters, it was something that was occupying us day in and day out. So we have now come to an understanding that it's so fascinating in all dimensions for the research, for analysis, simply to challenge your mind. It's a great idea to talk about. So communications. Why is communications different from simple conversation? Communications can lead to actions. They are actionizable. So if a Gen AI is generating a communication, it is actionizable. How safe or how how risky are we positioned? Let's see what it is all about. A scene of interest, 360 degrees camera, raw frames, local computer for processing, encoded ERP frames through wired wireless network, public edge media served for transmission. This is something which I was using for some time as scene analysis. Everywhere we go, we are seeing surveillance cameras. How do we generate a 360-degree camera? Can we position the camera properly? So we need some processing power, a model that will tell me how to generate that 360 degrees view. And how is it getting transmitted, whether we like it or not? The communication systems are doing the same. It has to chop it into raw frames, send it through computer processing, encoded, public edge media server for transmission. It receives, transmission tower receives, and then at some point in time, virtual reality using weaving 360 degrees scenes. So the frames are coming. You need a headset to put all those frames together and then work on it. I was very fortunate to get an opportunity to work on the handicrafts. Dr. Santosh Babu, IAS, who was the chairman and managing director of the Tamil Nadu Handicrafts. Uh, uh, he was there at that time. He brought in the idea of augmented reality and virtual reality. We are talking about it, immersive learning technology. There are sessions on that. You have gone through that. So what were we using? We were using it as a virtual showroom. It's just a virtual reality. The artifact can be anywhere, but it'll give you a feeling that the artifact is like that. You can turn, you can rotate, you can see, you can virtually have a feel for that artifact. So we were trying to build it. It was a nice exercise, piloted, and then it went into operations up to some time. People changed, and we also moved out of that committee. But it was a good exercise to pilot it. Several years back, use of generative AI for executive communications. They're actionable. How many people are using? Gartner says the same. Senior communication leaders are using generative AI, 16%. We are piloting the use of generative AI, 48%. We are investing 31%. We have no plans to use generative AI. So you see those who are piloting and currently using, 64% of senior business communication people are using Gen AI, ChatGPT. Other executive leaders, 35% of them are using. So it's operational. The generative AI, all these ChatGPT and others have gone operational into communications. The distinction that communication has is actionizable. That's a terminology which we have been using. Immersive communications, that's what I was describing. You see how much of background processing goes on before you reconstruct a scene with the virtual reality equipment. VR with HMD, the left bottom corner, that is the time when everything is coming together in a headset. We strongly believe that that is how we are seeing things in our mind. Our mind can imagine many things. But what is that processing that mind is doing? Maybe the headset. It is getting frames, it is rotating, turning, making things move, and then we are seeing the real imagery. The 360-degree camera, an onboard computer, aeroplanes are flying, unmanned aerial vehicles, drones are happening. They're all capturing images. The Google Maps captures images at a frantic speed, assimilates. As you drive the car at something like 80 kilometers per hour, the map is still working. Where in a car? It's not a supercomputer. It is just working. The map is telling you where it is, where the traffic is congested, what are the alternative routes, at what speed. 80 kilometers per hour. Even more than that, it will tell the same. But please understand that we have got into a way of working with these machinery which we didn't imagine even 10 years back. The multimodality, the sheer volume of the data was daunting. Now it is not true anymore. It's actionizable because the Google map is communicating the route. As the driver moves, he's moving. It says go left, blindly turn left. We don't care where we are physically. The Google map instructed you to turn left, you are turning left. It's a common joke which my family enjoys when we drive out. It is telling we are going. Google is telling you go right, we are going right. Google is telling you go left, we are going left. We don't want to do anything more than that. Usually we are right, we'll reach the destination, but suddenly the road is under repair. It happened 2-3 times. There are some video clippings that tell that they did not know that the bridge broke. But the Google map said you zoom past, you will see a bridge. They got onto the bridge and fell into the river because the bridge was broken. So what we tell under those conditions of accidents, see, it is not updating at the rate it should update. It did not know that the bridge has fallen. How do we know the bridge is there, not there? These are all the concerns. The same thing, please remember, it can happen with the essays. If you simply cut and paste, we are likely to be caught at a higher level where it is really a thin rope walking because the parameters are contradictory to one another. At a functionality level, it may appear easy for a systems designer, for an operating systems designer. But at parametric level, it becomes it's a knife-edge walk. This is how communications are happening. A simple example, immersive communications. It's an offline process, LLM validator, data augmentation, data set cleaning, sample data set. It is not trivial anymore. That's the point which I wish to make, but there are hazards. There are threats. The drift is obvious. Why didn't it recognize that the bridge broke? Typically, some drift has happened. It didn't recognize. The Google map didn't update itself that the bridge has broken and the car fell into the river. Once or twice it did happen. That bridge, the entire exercise was happening and we got stuck in a no man's land. But we can reverse and come back. We are just doing a holiday driving. LLM code generator, LLM description generator, these things can happen because we are acting on communications. Communications will be actionable. Objects annotating, web servers, media servers. Remember how much of processing power we have been hoping to get, and what we got is still making us think we need more. Edge cloud servers, everything is there. We want more and more. Presentations, is Gen AI the new PowerPoint?
Dr. Gopal, we
One
have a
is,
couple of questions before we move on
yes,
to
good. Very good, very good.
So Sonali has a question. What are the biggest challenges in building chatbots that can handle open domain conversations naturally?
One is that idea called natural. Whatever you are talking natural, we are nowhere near. Anything that we are sending across a channel is abstracting the source and the receiver. Both of them are abstracted first. What we are talking is going across the channel is dictated by the channel properties. Today, we are telling that the channel properties are of no consequence. It is great, except that who is the person who said it, who is the person who heard it, are abstracted. Biggest challenge. Natural conversation is banking on who said it, who heard it. That is abstracted. Then comes the next one. The properties of the channel, whether we like it or not, are expected to be in adherence to what is called the information theory. That is, we make sense out of it. Hello? Hello?
Yes.
Okay. So there was I think there was a crosstalk somewhere. So what's happening is the source and the receiver, the sender and the receiver need not be known. But that's the first requirement in conversation. Who is conversing with whom? Makes sense. Then the next one, as I said, was we will have to still be true to the communication channel. Otherwise, we cannot rule out the garbage in, garbage out without any verification. If we do not know any bounds on what is happening on the channel, how will you know whether it is correct or wrong? Whether what I said is going? In other words, we want all these exercises to be safe, secure, and reliable. Otherwise, why will you use it? Then comes the third challenge. 3.5 billion parameters is not enough to understand language. We are nowhere near linguistics. Conversation banks on linguistics. If we do not understand linguistics, we are not doing conversation. Top 3 challenges. Does it answer your question, Sonali? You can speak. Hello?
Or you can put it in the chat. Sonali can mention in the chat. There is a
Okay.
couple of more questions that she's
Yes, I've seen
typing.
that.
Yes. Yeah. She has a
Okay,
couple of
okay.
more questions. I will just read it out. What are the limitations of current transformer-based architectures like GPT or BERT for dialogue management? And maybe I'll say the next one also, maybe they are connected. Can you throw some light on open source chatbot technology?
I suppose the second question is easily answered by simply going back to one of my slides after screen sharing. I will share the screen again and go back to my presentation, go full screen and move back. You see, these are the alternatives. We need a model. Google, OpenAI, Anthropic, Microsoft, privacy concerns may arise. There are so many models. You see, this many models are there. Currently, OpenAI is a market leader and its brand is GPT. There are many, some of them are open in this. NVIDIA, it's open. So I hope this answers the second question easily. The other question that you have put in the chat is something which I am looking at again.
What are the limitations of current transformer-based architectures for dialogue management? And then she's saying, what would be a good research problem statement for a student starting in chatbot technology?
Very good. That's nice. I'll come to the question here. What are all the limitations? There is a SWOT analysis page.
Yes.
Large language models. This is the SWOT analysis. I like to talk like this on many topics related to technology. Feels good. It has its strengths, which we are listening to. It has its weaknesses, unstructured input, data productivity suits, data discovery. How will it discover? Maybe one paper written in December 1955 has a direct answer to your question. Undisputable, well established. Science is like that. Well established. So as we keep talking, the literature survey is never complete. But we say reasonable literature survey has done. The same thing holds good for ChatGPT. Will it be able to tell me what is the next research problem? Very difficult now. Typically, for a good research scholar to arrive at a problem definition, it takes an year to get a grip on what is a problem. And unless you have a problem, you don't see a solution which is impactful. In other words, having a well-defined problem is half solved. Arriving at a well-defined problem takes time. We don't see the ChatGPT doing it for us. It is not defining problems. It is telling us that the corpus of data in any model which can be accessed in a Ziffy because of the supremely fascinating computing power, multiple computers, parallel processing, multiple thread, millions of activities, and bandwidth may be a bit of a concern like what we are experiencing now, but still the chat GPT is good. Online, this stock is going through an analysis which we didn't expect. Whatever we are doing now on this is on the YouTube. As the YouTube lecture is going on, analytics are already generated. It's something which we'll have to look into. Weaknesses, opportunities, threats, inference. So the threats are always there, the drift which I have described. Does it answer the questions, Sonali? Okay. Computing power, yes, we will have to pay some small amount. About $10, you will get a phenomenal computing power at your fingertips right now. Maybe that also will go away. Open Power Consortium was aiming at giving that kind of a phenomenal computing power for processing. But then you have to be a member of the consortium and we have to contribute. We have to contribute to the progress of that consortium. I have a promise to keep on open systems, so I tried that. Some of my students work on commercial basis. They're all there, they're all priced. Open systems model works in that manner. You contribute and go ahead. We need to be developers. No problem, Sonali. I enjoy all these questions and you are putting me on a right track. Please don't hesitate. I am told that Oracle was giving some free time for computers. Most of the business industry exercises are now happy with this idea called open power, and we thrived on that open systems, so they are sparing some time. Databases definitely, Oracle databases definitely gives. So let me see, let's proceed to the next set of topics. There are three topics which I saw in the title of the presentation that I was given to talk on today. Communications is one major topic, just 3 slides. This is the model of communication, a case study, which you can have many use cases generated. A 360-degree camera, frame by frame, it is going over the network, reconstructing, VR tools, AR tools. Communication is something that is actionizable. Many people are using it. Immersive communications. Presentations. The next one is presentations. Is Gen AI the new PowerPoint? Maybe. Automatically your PPT is getting generated, which is something fantastic. Opportunity to automate. You don't even have to generate your PowerPoint presentation, though I still believe in applying my own mind and making the PowerPoint. Sequencing is not coming out well to my taste. PowerPoint is not the question. If I have to use the PowerPoint, am I using it with conviction? The answer is no. Unless I make my PowerPoint presentations, I am not there in my lecture flow based on PowerPoint presentation. The lecture is based on a PowerPoint presentation. The generative AI, there are tools. You please read through the content on the Future Skills platform. One or two modules are on automatic presentation generators. Automatically it will come in the format that you want. Administrative, presentation makers for PowerPoint, Google Slides, Plus AI, Copilot, Slides AI. They are 3 good tools, and I have been exercising on Copilot. Copilot is now a part of many meetings. Copilot is on, you get a prompt saying that, are you okay? If the AI Copilot is on, it is on. Copilot is something which is nice. It is taking the meeting notes. So much of things have happened. Copilot is making the points out of a meeting. Minutes of the meeting are generated by Copilot. It will also form into a bullet or an image format. AI text content does not change based on style. Simple theme chooser. So there are some limitations, but the good experiments. Automatically, Copilot is generating meeting notes. It's being called notes. It is not being called minutes, not fully legal. It generates. By the time the meeting is over, it is generating. And now we come to the prompt. There's just 2 slides on presentations, 3 slides on communications, but everything that I have been speaking until these slides has an impact on the quality of the PowerPoint, quality of the communications. If 64% of the senior leaders are banking on generative AI into making communications, it is reasonably good. But what about that 36%, the half emptiness of the glass? That's a challenge for the researchers. Sonali will produce 3 PhDs tomorrow on that simple point. 64% of the senior leaders are happy with the communications. What happened to the other 36? 3 PhDs can be produced on that. Same thing with the PowerPoint. I have first-hand experience with Copilot. Slides AI I have seen, but then it doesn't give me a feel that I will be talking on those slides. Ages back, this concern was there. When the non-formal education began, the idea of creating a slide deck on a given topic started. So it will go to several trained people, instructors. Roughly, they are building on that particular deck of slides. On that topic, that particular deck of slides is the bounds. They talk based on those slides. But the individual characteristics can differ. The content is roughly the same. If that is the concept, then the slides AI seem to be doing okay. It will give you a set of slides on any topic. It's up to you to build your stylistics. Some of them tend to be a bit awkward. You think it's not fitting into the title, but you have to manage that. Prompts. Prompt is something that is not so new to us. Command line interfaces, even the earlier talk I was talking about it. Command line interfaces implode one to remember the commands. What is the trouble with CLIs? You have to remember the command exactly. One letter this side, that side, it will do something which you did not think it will do. Unimaginable errors will happen. You have to remember the command correctly, and these commands have weird spellings. So for example, in the case of Unix, we had a command called create. It's not create, it is create, C-R-E-A-T. And because the E is missing, it becomes something which is a totally different term. Nobody understands what it is. It's create. It is useful for a command like that. So there are so many such commands. RM is remove. RM can be remake. Why not? So these are certain ambiguities, the difficulties. In other words, command line interfaces draw a lot of human attention. Lot of human attention in terms of memory, in terms of spellings, in terms of crispness in typing out at the command prompt correctly. All these things are still a load on the human. We came a long way. I was working on POSIX standards. There were 13 user groups at a time when I was working early 90s, and we had the IEEE POSIX standard document given to us. Few pages could be photocopied at that time. Now I think the entire book is there. Relevant working group topics we could take photocopies, but then that's how it is. We have to be very clear. We have to understand that the interface that forms the basis for building your GUIs. It's a standard. The interface standard is something which we'll have to look into. Others are types of interfaces. DBase 3 Plus had a nice idea called assist. DBase 3 Plus soon went away. I'm talking about late 80s and early 90s. Foxbase replaced all these things. But DBase 3 Plus championed, pioneered an idea called assist. Just type assist. automatically you get into a different screen. The command takes you to a different screen. Now at each and every step, it will tell you what are the alternatives. You have to choose one alternative. Eventually, you will construct a very big command. Another way of prompting. Database is not, there's a prompt. It's just a prompt idea that tells how to build prompts. The reason why I'm talking is the ideas are there. The most effective, the most efficient use is happening now. 7 decades of progress in this topic is something which has taught us very stern lessons. We have learnt well from those lessons. So today we are able to build something called prompt and cascading prompts engineering. Then came the GUIs, visual programming paradigm, graphical user interfaces. Windows championed GUIs, and today we are stuck with GUIs, standard elements wherever we go. Visual programming paradigm, usability engineering. Give me an interface design, I will tell you how usable it is. I have been doing my own research after completing my PhD in the area of usability engineering. So user prompts to generative AI to AI generated response, going back into the knowledge database, conversation history, contextual information. It builds, it builds, it builds. It's a cycle. AI generated response goes into the conversation history. It is captured. It builds, it builds, it builds, it refines. That's the power of a model. The model tells how it will learn. That's a case of learning. It will refine, refine, refine. As more and more people use, in 6 months, it was 100 million users of ChatGPT, still the market leader. Refined, refined, refined. It comes out with correct answers. Why our prompts matter when engaging with ChatGPT? As the likes of ChatGPT have grown in popularity, so too have discussions about its impact on the workplace. With the new technology, it's likely that new jobs will emerge that capitalize on the new capabilities. So we are talking about new capabilities. We talk positive about technology, whether we like it or not. Technology has transformed the entire way in which we live, we work, and then we progress. There's no choice on that. It has been a change agent. Technology has been a change agent. How to deploy it correctly to transform ourselves is a question. New capabilities, new competencies, and we have a new role called a prompt engineer emerging. Did you give the right prompt? Did you give the correct prompt to make an optimal answer happen? A role called, a capability called prompt engineer. Please throw back into your own minds what was happening when Google was beginning to happen. When Netscape was there, Netscape Navigator was another browser. Google Chrome is now almost dominating everywhere. Netscape Navigator was there, Mosaic was there. It was a good exercise to compare. What happens if I give these words into the search window on Netscape? What happens if I give this onto Mosaic? What happens if I give it on Google? Now, market forces were such that today we don't talk about Netscape Navigator. We don't talk about Mosaic. Did you Google everything? Yes, we Googled everything. Nothing wrong with Google. Because any search engine is like that. All models are wrong. Some models are useful. So how useful it is for you, you will have to decide. Therefore, every organization is likely to build new capabilities. New roles, new job roles will emerge, like prompt engineer. So are we giving the right prompts? Research from University of Southern California Viterb School of Engineering explores how we can construct prompts that get the right kind of answer, with the paper highlighting the importance of interacting appropriately if we want feedback that is robust and reliable. We demonstrate that even minor prompt variations can change a considerable proportion of predictions. Researchers first looked on how asking for responses. It's a good research topic, Sonali, for you to explore on Indian conditions. If you can create something for Indian conditions, the content in multimodal, multilingual, it will be a very good research proposition. Then they examine small changes to the prompts. A small change, one letter change. You can see how the content varies. There are sensitive topics to talk about, testbed jailbreaks, tricks to get around filters when dealing with sensitive topics. But how will a typical individual conclude whether to go ahead or not? That you will know only when somebody goes ahead and risks. Otherwise, we don't know. ChatGPT is like this model is like this. It's correct, it's good. Generative, therefore, my submission is that institutions will build more capabilities, new capabilities which we did not think of even 3 years before. And such capability will be necessary at a rapid pace. We are looking at so many people who are aware of these things. All of a sudden, make use of technology as a business change. And it must happen. Garbage in, garbage out, this I have mentioned. So how do we convert it into attentive inputs to precise outputs? What is garbage in, garbage out is understood. That is still true. Why, what, and how? How will you decide quickly? As ChatGPT is throwing out everything in few seconds, few minutes. How will you decide whether you can go ahead or not? It's up to you. It's a new capability. It's a demand on new capability. The SWOT analysis slide, which I showed, which is what I normally like to do with technology. If everything is fully advantageous or fully disadvantageous, you and I are of no consequence. Only when something is having a good number of advantages, good number of disadvantages, the human will shine by leveraging that tool to the advantages. That is a human advancement which we have to envisage using technology. So that is where we are talking about how to be confident on that technology. The structure of an AI prompt, we are still worried that the prompt needs a structure. A format is necessary, a reference is necessary, a request is necessary, a framing of the prompt is necessary. This is Don Norman's group. Jacob Nielsen and Norman, they got together. They were the pioneers in usability engineering. And it's nice to know that they have come out with a framework. The AI prompt still has a structure. We have not gotten out of structure. Without structuring, we are not able to do much. The human mind is exceedingly good when things are structured. When things are totally abstract, we are not able to get focused enough to actionize. That's the difference. There are a good number of people who revel in abstractions. I've had a personal experience, first-hand experience of a space that we didn't think is possible from what we started with on the desk. A space that can be imagined, a multi-dimensional space can be imagined. That's power of abstraction, no dispute. But then what we are talking about are actionizable. For that to get into action, we need a structure. 12 ChatGPT prompt techniques, direct instruction, multiple turn conversation. All these things are prompting techniques. So we'll have a prompt engineer, a short certificate course on prompt engineering, prompt design and development is necessary. No dispute on it. How much that fellow will earn, what is the growth prospect, that's not my concern, but I can tell that this is necessary. Otherwise, the content that is coming out of all these billions of parameters will still have 3 question marks at the end. Do you believe it is correct? Do you want to actionize? If you want to actionize, at what level? Will you talk to your president to do this or not? These are all the concerns. 11 best ChatGPT prompts for better results in 2025. This is a great research paper recently published. VLA Lab, Mohammed bin Zayed University of AI. They did a great experiment. They experimented with 26 different prompting techniques. recently published, still in the archives. It's still not yet out in the print. Those of us who are alert on these topics, we get to know this. Very recently, it was uploaded on the archives, and very soon it will appear in some learned journal, which I will not mention right now. This is the preprint version that I was fortunate to read, and improved response quality, factually correct. We are still alert on that. That's how it is. Principled instructions are all you need for questioning LLMA half 1.1 or 2, GPT 3.5 or 4. Please remember the title. It's a great title in itself. Principled instructions are all you need for questioning. It is not randomized prompt. We should have some principles governing. Human without principle, explain the concept of climate change and its potential effects on the environment in one short paragraph. Not happy with ChatGPT answer. Human with principle, the prompt is very nicely structured and the answer shows a remarkable improvement in the quality. You can read this slide later. Like this, we can construct. Application security, Open Worldwide Application Security Project, WASP, is a non-profit foundation that works to improve the security of software. Top 10 LLM applications. OWASP Top 10 LLM Application Project aims to educate developers, designers, architects, managers, and organizations about the potential security risks when deploying and managing LLMs. There are security risks. So we need prompt engineering to ensure safe, secure, and reliable work on ChatGPT. I'm almost coming to the end, Kamna. Automated prompt engineering assistant. These are all happening. We are still looking at how to give the prompt, but the latest cutting edge technology is to have automated prompt engineering. Is this prompt quality good? It will tell you a metric. Point 3, the question quality is like this. So prompt engineering, query crafting, chain of thought. Puneet Agarwal was talking how to chain the thoughts. Chain of thought, popular technique consisting guiding LLMs, prompt chaining in AI systems, formal verification. This is necessary. Otherwise, we are not confident about what the generative AI is giving to go ahead and use any beyond a typical knowledge pursuit or advanced search engine level. Hoping to become transformative, we need to mature this. I mentioned this, I used this slide earlier on also. Thank you. And this is the last slide which I would like to retain. Aware, we are only aware. We're beginning to explore. That is the position we are today. Beginning to explore. We should become operational. We are fully not operational. We should become integrated, autonomous, and then transformative. But then at the very beginning, the tool was called a transformer. We are aiming to go to that. It's a far-sighted idea. From 2017, 8 years, we are at aware and beginning to explore. Another 15 years, we may talk transformative. Thank you.
Right. Thank you so much, Dr. Gopal. That was a very in-depth and informative session. Thank you so much. Thank you to you, and thank you to all the participants for joining in. We will again reconvene tomorrow at 6 p.m. for the next sessions. So I'll request everyone to be on time. Please note that Zoom is noting your attendance, and attendance is compulsory if you want to take the assessment and to get the certificate from AICTE. So please make sure that you attend the sessions. Thank you so much. Thank you, Dr. Gopal. Thank you so much.